Hello everyone. In this video, we're going to verify the given trigonometric identity, and we'll start on the left side and work our way to the right side. So we can start our proof by just writing the left side exactly as it appears without any modification. All right, so in this type of expression where we have just the first power of a trig function, given that if you recall our trigonometric Pythagorean identities, which consisted of sine squared theta plus cosine squared theta equals 1, then the close relative, which you can obtain by dividing both sides, and therefore because of the split all terms by cosine squared theta, we'll end up with tangent squared theta plus 1 equals secant squared theta, and also dividing both sides of the original Pythagorean identity by sine squared theta will give us 1 plus cotangent squared theta equals cosecant squared theta. So these three fundamental identities that are available to us all seem to have only squares in them. The one that's going to be of interest to us is going to be this middle one, because if I take that and I solve it for tangent squared theta, I end up with secant squared theta minus 1. So I have secant theta minus 1 here. I know that if I use the fact that the product of two conjugates yields a difference of two squares, then I notice that if I take secant theta minus 1 and I multiply it by secant theta plus 1, I'll end up with secant squared theta minus 1, which I can then replace with the tangent squared that I need. So that's the game plan here. So we're going to go ahead and take that expression on the left, and we're going to multiply the numerator and the denominator by secant of theta plus 1. This is a common strategy that we utilize. So now we notice that we have negative cosine theta times secant theta plus 1, and since it looks like I want to have only cosines involved, I'm going to go ahead and replace that secant of theta with 1 over cosine theta plus 1 over, now we know from what we discussed here that the denominator is now just going to be secant squared theta minus 1. So now if I go ahead and distribute this negative cosine theta, we'll end up with negative 1 minus cosine theta over tan squared theta. So that's pretty much the result we wanted to obtain anyway. If you want to be really picky and make it look exactly the same, of course you can write the negative cosine theta first and then the minus 1 over tan squared theta. And now we have obtained the identity that we wanted. Sometimes in applications like my math lab, they're trying to make sure that you're not just looking at the choices and picking one, so they may skip some of these steps. For example, I've seen it before done where they jump from this all the way to this step, or basically skip several steps. So you have to, when you get a problem like this and you're using a technology such as my MATLAB, what you'll want to do is you'll want to completely ignore if it's given to you in the form of multiple choice, you'll want to ignore the multiple choices and you want to just sit there and prove it on your own, which is what's expected by myself and most other instructors on your worksheet. And then once you do that, you'll be able to pick the right one, even if several steps have been skipped in the process of obtaining it. So that should do it for this problem. Be safe until we meet again.